Hello and welcome to this video on Unit 4, Lesson 1, CPCTC and its Converse. We are entering our unit on congruent triangles and proving that two triangles are congruent. And we're going to start with talking about what these two rules mean for congruent triangles. So two figures, by definition, are congruent if and only if one of them can be obtained from the other by a sequence of congruence transformations. You could also answer this a sequence of isometries. That could go in the blanks. Or rigid motions. They all mean the same thing. This means that we are including reflections, translations, and or rotations to map one figure onto the other, showing that they are the same, that everything is preserved. Angle measures, side lengths between this, collinearity, all of those things are preserved. So by properties of isometries, two triangles which would be congruent and fit this criteria will have corresponding angles congruent. That is because angle measures in an isometry are preserved. Sorry for the announcement interruption. And corresponding sides congruent because the distances are preserved in the figures. So these are two properties that all congruent triangles will have. If we look at these two triangles here, we can see that they are congruent. It looks like this one's been rotated around a little bit to get this one. They are listed as being congruent, and this is called a triangle congruence statement. So triangle ABC is congruent to triangle DEF. The statement must be written in order of matching parts. So for instance, because A is written first and D is written first, that means angle A is congruent to angle D because they are both written first. B and E are second, which is why angle B is marked congruent to angle E. C and F are last. Angle C is congruent to angle F. So we can say that because the triangles are congruent, all their corresponding matching angles are congruent. So angle ACB, which is angle C, matches angle DFE. You must go in order of matching parts when you name them. Angle CAB would match angle FDE going in the order of parts. And then angle B is just named with one letter because sometimes you can do that and sometimes you can't. So it is congruent to angle E. Not only are corresponding parts congruent, corresponding segments are congruent. So segment AB is congruent to segment DE. You can get it from the name or from the picture. So AB is congruent to DE. Segment AC is congruent to segment DF. AC, DF. You can get it from the name or you can get it from the picture. And then finally, segment CB is congruent to FE, which means you can get it from the name or you can get it from the picture. So you don't have to be given a picture to match congruent parts. As long as you have a triangle congruent statement, you can do that. This is what CPCTC stands for. If you have two triangles congruent, then you can say all their corresponding angles and sides are congruent. Corresponding parts of congruent triangles are congruent. You have to know the triangles are congruent to do that. Now let's talk about the converse of CPCTC. It says basically the reverse, because we know the converse is when you switch the hypothesis and conclusion of a statement. So if two triangles that we don't know are congruent have all corresponding parts congruent, then the two triangles have to be congruent. So if we look at this information that we're given, let's say we're given that AB is congruent to DE in two triangles. AC is congruent to DF, and CB is congruent to FE. Let's say we're given that. We're given the angles that match are congruent. If we're given that, then we can conclude that the triangles are congruent. Like if I were to take a picture and mark on it everything we were given, AB congruent to DE, AC congruent to DF, I'm doing the third one, CB congruent to FE. All right, that's three sides. Angle ACB congruent to DFE, and then CAB congruent to this one, and then angle B congruent to angle E. If all three sides and all three angles are congruent, I can say triangle ABC is congruent to angle DEF. Also, you can then name the triangles in different orders as long as you match them up. If you decided to call the first triangle ACB, then in going in order of matching parts, ACB, you would have to go DFE for the other one. So often once I do this, I ask my students how many ways are there to write a triangle congruent statement, and they will usually say 6. Because what if I called the first triangle BCA or BAC? Or let's say I called the first triangle, started it with C and called it CAB or CBA. So you have to name the second triangle matching the order. CBA, DFED. CAB, FDE. All right, so if I called the first triangle BCA, it would be EFD. And if I called the first triangle BAC, it would be EDF. And then some students will say there are 12 ways, because what if you start with the triangle FED first, and then you can write it 6 more ways? Which I would say, touche, that's true, you can. All right, so we know that with CPCTC, it's very important you know the triangles are congruent. Then you can say stuff inside them is congruent. You can use CPCTC to justify that in a proof. The converse is if you're trying to prove triangles are congruent, you would have to show all 3 sets of sides and all 3 sets of angles, and then you could say they are congruent by converse of CPCTC. We will practice using both of these in an example proof in a minute. Right after we talk about the properties of equivalence relations for congruent triangles. So reflexive property is that every triangle is congruent to itself. So triangle ABC is, of course, congruent to triangle ABC or CBA, or if you choose it to name another way, you can use reflexive to justify that. All right, so if triangle ABC is congruent to triangle DEF, then DEF is congruent to ABC. You can use it to flip the name around. And then transitive, if ABC is congruent to DEF, but DEF is also congruent to XYZ, then I can say triangle ABC is congruent to triangle XYZ. So those properties work for congruent triangles. All right. Let's try a proof in which we are going to use CPCTC. So we are given that the triangles are congruent. That means using CPC, we can say any parts in them are congruent. Triangle ABD is congruent to triangle CDB. That is given. All right, and we want to prove in this proof that the lines AB and CD are parallel. I'm not going to mark them parallel. I'm marking them with dotted, showing that that's what we want to prove, but we don't quite know it yet because it's dotted, so it's not quite true yet. But if we think about it, if we want to prove those lines parallel, and we think about the fact that, if the lines are parallel, then BD is going to be a transversal. So if we could show that a set of alternate interior angles is congruent, that would be enough to prove the lines are parallel. So I am going to look and see if I can come up with a way to prove that set of alternate interior angles is congruent. Well, since triangle ABD, this triangle up here, is congruent to this triangle down here, I know corresponding angles are congruent. Like matching angles, not corresponding as in parallel lines and corresponding angles, but they match also. I know that angle B in this triangle has to be congruent to angle D in this triangle because they are corresponding parts of congruent triangles. So I can say this angle here and this angle down here are congruent because they are corresponding parts in matching triangles. So I can't name it angle B though because there are three angles with vertex B. So I'm going to call it angle ABD is congruent to angle CDB, going in order of matching parts by CPCTC. Corresponding parts of congruent triangles must be congruent. So now that I know those angles are congruent, I can say the lines are parallel because we have a theorem that says if two alternate interior angles are equal, the lines must be parallel. So I can say AB is parallel to CD. You can call it the converse of the alternate interior angles theorem. Or you could say alternate interior angles congruent implies parallel lines. You could say it that way too, because that's what the converse of that theorem says. So we have now proven that AB and CD are parallel. Proofs like this are going to come in handy when we do our units on quadrilaterals, because I will have you prove things about this shape, which is a parallelogram. So we'll be using this in further units. All right, now let's do a proof that involves using the converse of CPCTC. All right, we have a lot of given information because in order to prove the triangles are congruent, we're going to have to show 3 sets of corresponding angles are congruent and 3 sets of corresponding sides are congruent. Just like up here, we had to show all 3 sides and all 3 angles congruent in order to say the triangles were congruent using converse of CPCTC. So there'll be a lot of given information. D is a midpoint of AF. Okay, so that means we're going to end up putting in the proof that these 2 segments are congruent by definition of midpoint, but we have to do that before we can fully mark it. Okay, we have AB congruent to DE. That was directly, blatantly given, so we can mark those congruent. We have DB is congruent to FE. I'm going to have to use 2 lines because there's just so much given information. DB is congruent to FE. All right, we have some parallel lines. AB is parallel to DE. So I'll mark those. And we have DB is parallel to FE. Okay, and then finally we have angle B is congruent to angle E. All right, so I'll mark that. All right, great. So we have all that. So we already have, in terms of having 3 sets of sides and 3 sets of angles congruent, we already have 2 sets of sides congruent and 1 set of angles congruent. So we just need 1 more set of sides and 2 more sets of angles. All right, great. Well, the set of sides is going to be easy because we were told that this was a midpoint, point D right there in the middle here. So that means these are going to be congruent by definition of midpoint. So I'm going to have another set of sides done. AD, oh, I forgot to put, this we'll call step 1 because I'm using 2 lines. I'm definitely going to number my steps. Okay, so AD is going to be congruent to DF. That goes in order of matching parts because I'm going from the acute to the obtuse, the acute to the obtuse by definition of midpoint. Okay, now we got to get our 2 sets of angles. All right, well, if I look at the fact that this line is parallel to this one, and we have a transversal. I'll mark those for a minute, but I'm going to go back and unmark them. And we have a transversal here. We can see this angle and this angle are corresponding angles and have to be congruent. So I'm going to unmark all this so I can go back and put that in my proof, but not mess it up too much. There we go. All right, so I'm going to say angle A is congruent to the other angle I'm going to have to name with 3 letters, angle EDF. All right, and that's going to be because parallel lines imply corresponding angles congruent, or the corresponding angles theorem. You can call it the corresponding angles theorem. Okay, and last but not least, if I mark these parallel lines using the same line as a transversal, I can see that I have another set of corresponding angles there. Okay, so step 4, angle EFD is congruent to angle BDA, going in order of matching parts, for the same reasons. All right. So now I have those congruent. Those angles congruent. So I did both sets of my corresponding angles. So now I have enough to say that the triangles are congruent by converse of CPCTC. Sorry, I used the wrong pen thing that turns everything into straight lines. I didn't mean to do that. Make sure you write the given exactly, or the proof exactly like they have it written here. Okay, so a couple other things I want to mention. You can number angles sometimes and use those instead of the 3-letter angle names. I'm fine with you doing that so long as you number them on your picture. And also another thing I want you to understand, we are going to use this rule CPCTC a whole lot this year. But this converse one, we're not going to use very much because we're going to, in our coming lessons, learn shortcuts for proving triangles congruent with some different theorems that we're going to learn. So you will only have to use converse of CPCTC just a little bit, and then we get to throw it out the window and learn some shortcuts that you're going to come to appreciate. So thank you for joining us for this lesson. Our next one, we will start learning some triangle congruence rules that make our proof shorter.